using data from a sample survey to estimate a population mean or proportion. That's the key part we're doing. We're also going to be interested in developing the idea of margin of error. And so I want to try to motivate this by talking about a particular Gallup poll that was taken in October of last year. And one of the questions they asked was, do you think President Obama or Governor Romney would be better at handling the economic problems of the country? And they published that results of the survey. But what I'd like to try to do is have us uncover what they would publish. Does that make some sense? So this is the data that they had. So one question I have is, are they interested in trying to find the mean of a population? Are they interested in trying to find a proportion?
I believe that it's a proportion that we're looking for.
Okay.
Of the Gallup poll.
Okay. And why did you say that?
Because we're trying to basically find a percentage.
They're trying to estimate what percent of the population has that feeling. Now, they're going to find a proportion, and can one of you find out what is the estimated proportion based on the sample? So we're at that part of the course where we're taking a look at results from a sample and trying to figure out what it means. I start the class by taking a look at the results of a political poll.
I would say there's a percentage of people, 56%, that believe that Romney is more capable.
Okay, so 56%. Do you think that the Gallup people are going to say, based on their random sample, that exactly 56% of the people feel that Romney would do a better job for the economy?
I believe no, because you have to find out like if they satisfy like the normal model exactly, and then also every time a sample is taken, it won't be the same data every time. So you have to do like the process of normal model.
What Audrey is talking about in part deals with a margin of error. Now, margin of error is a sense of how confident we are about our results. We're never going to be absolutely confident, no matter how many people are surveyed, unless we survey the entire population, that exactly this number favors a particular point of view. But we can be pretty confident. And that's the activity I'd like you to work on today. Sometimes it's a very teacher-directed lesson or presenting information maybe that they've read before. Other times, like today, the kids are working in small groups under some direction. And it allows me to give kids help in small groups, walk around, see what their needs are. And this gives me ideas of what I might need to do in the future also.
Yeah, we gotta find standard deviation first.
So we multiply p times q.
Which is what?
Q is 1 minus p, which is just 16.29 or 16%.
16%?
Or 17% for y'all since y'all using 83.
Okay.
Check the standard deviation for me. Make sure you get 0.018. Wait, what did you do? What is that? What was standard deviation? 0.837 times 0.163 divided by 350. Square root of that. Did you get that? Something different.
This is not good. Hold on, let me put it in.
Oh, no wonder. I did it backwards.
My bad.
For me, the heart of Common Core are the 8 standards of mathematical practice. So math is not just about learning the quadratic formula. It deals with perseverance, for example. That's one of the standards of mathematical practice. I'm much more cognizant of that now as part of the last 3 years of my involvement with Common Core.
Okay, quick question.
Yep.
So, okay, in the calculator, why did you put 0.975 instead of 0.95?
Good question, okay? And so this has to do with the fact it's on two tails, okay? So we want this to encompass 95% of the data. So it's going to miss 2.5% on the left and 2.5% on the right.
Okay.
And so if 100 minus 2.5 is a 975.
Okay.
Does that make some sense?
Yeah.
And so you're going to make a similar statement here. So this is your estimate, 0.837. And you know that we don't know exactly that's right. So what we want to say is, we're fairly confident about that. We want to be 95% confident. So basically, we're going 2 standard deviations on either side. And so, if Gallup was doing the poll, then the Gallup organization is, we're pretty confident that the real result will be between like 80% and 88%. In fact, we're 95% confident about that.
When he does it, he does 4. So when he get ours, it'd be like 0.789 something, and then we just got 0.88 or 0.89. So I was like, what? He confusing us.
He's
'Cause we got the
confusing
same answer, and then he's not rounding to.
He's not rounding?
No.
Oh my God.
No.
Wow, I wouldn't associate with him outside of class if he's not rounding. What?
Yeah.
You don't have to round?
You have to round before you have similar answers, because if you have this, the data would be not the same. Because basically, we're doing the same sample, but his sample answer is wrong, I think.
Well, it's just not rounded the way you would prefer it to be rounded.
Yes.
Okay. So it's like a difference of opinion among friends.
Yeah.
Okay? The other thing I was interested in doing was having them use some technology in different ways than we have done before, so that they could use this to solve problems. So go to this menu,
Okay.
go to Stat, or Tests, okay? And scroll all the way down until you get to A.
Okay. Prop zinc.
What right before the word prop?
Oh, 1.
A 1.
Okay.
And what do you think prop stands for?
Proportion.
Excellent. Okay, and what do you think int stands for?
The intervals.
Interval, exactly. This is the shorthand way for one proportion interval, okay? And it's one proportion z interval, okay? Does that make sense?
Yeah.
Wait till you find out press enter, see what happens. What's it asking you to do?
The X,
X?
the N, the C levels, and the calculate.
Cool, okay, so what is X in problem 2?
X in problem 2 is
Wait, that's the success rate?
Not the success rate.
the probability.
No,
Proportion?
no. Or what is N in problem 2?
437.
Yes, okay, so sample size, okay?
Yeah.
So what do you think X might be? What do you,
316.
say letter?
316.
316 is the number of successes.
Okay.
Does that make some sense?
Yes.
Okay. And what do you think sea level means?
Critical value?
The confidence.
Critical level?
No. Not the critical level.
And confidence interval.
Yeah.
Yeah, it's actually the confidence level, okay? And so they're asking you to do a 95% confidence interval. Does that make sense? Now, our friends at TI know you guys are students. You can either type in 0.95, which is what Tariq did, or 95,
That's why I put
okay?
95.
It can handle it. So go ahead, type it in. Don't type 100
I did that.
don't type 1,000,
I got 0.72 for P. That's what we got.
okay? And what else did you get? What do you get on top
The
of it?
N. Oh,
What else do you get?
oh, we got the standard deviation. The 2 standard deviation, the 95%.
Is it in parentheses?
It's a brackets.
Brackets?
Yes.
Okay? So it's not just the standard deviation. What else are you getting? What do you think that is?
This right here?
Yeah,
The confidence interval?
it's a confidence interval,
Okay.
okay? So the calculator
And that's what
is
we got.
calculating, and that's what you got. That's excellent, that's great, okay? Now, what you're doing here manually is really important, okay? But I will tell you that the calculator can also do the mechanics of this.
Okay.
Okay. You're doing really well. Each group discovered the calculator command, and I delayed in telling you the calculator command. Everything we've been doing about being able to calculate a confidence interval manually with the critical value and the standard deviation and the sample proportion is still very important. So don't forget about that, okay? I want you to type in this information in one prop z interval, okay? And I want you to give me a 95% confidence interval.
Well, we got 0.68. I say 0.688,
What's on the lower part?
0.75, .832 for the next one.
All right, 56 should have been in the middle. Is that?
No, it's, okay, and the full one was .6879. That was the full one.
Say,
Did you see 56 in the middle?
Yeah.
I think it should be
Lucia?
.54,
Okay, .54.
and then the other one is .59.
Here's an easy way to find the margin of error. Subtract these two numbers. Okay? Subtract them and divide by 2. Subtract, go .59 minus .54. Just subtract them. Even I can do that. And divide by 2. And so our margin of error is 2.5%. What we're going to be doing next week is looking at hypothesis tests with proportions. And so it's another part of inference. For me, it's essential that the kids have some ownership of this. So they're not just learning techniques in a vacuum, but they have some sense of what it means, how people in real life might use it. And so this sort of surveying is really important. And it turns out that the popular press really likes the idea that the margin of error is pretty small, like 3%. And so that's why when you see a political survey, they're going to be surveying around 1,000 people. And the reason they survey around 1,000 people is because we know the formula for the standard deviation. We divide by the square root of 1,000. And so this makes sure that the margin of error is this small. Okay, so do you feel pretty confident about confidence levels? Yeah. Cool. Okay, well, thank you very much for your cooperation, okay?